Okay, question number 10. An object x of mass 0.3 kg is, this is 0.3 kg, is traveling in a straight line at a constant velocity of 3 meter per second. Okay, let me assume this is your velocity u1 and this is your mass m1. Okay, on a horizontal frictionless surface, okay, object x collides with a stationary object y of mass 0.5 kg. Okay, so when you say about horizontal frictionless surface, which means whatever could be the distance, the velocity is the same, no external force acts on the object. When you get that clue over here, you can immediately say COM can be applied. Okay, now look at the position of the object here. This above, this is below here. Okay, like how you strike a coin using a striker in a carom board. After the collision, x moves with the velocity of 2 meter per second, and y moves with the velocity of v at an angle of 41 degree to direction of x before the collision. What kind of collision is this? This is a two-dimensional collision. Okay, now what is so special about a two-dimensional collision? So when the collision happens, just look at the line of impact. What is the line of impact? This is the line of impact, right? So therefore it hits over here. So this is the line of impact. You can apply COM only along the line of impact. Do not apply the COM perpendicular or along this direction line. Okay, this is what you need to apply. Okay, so first one is collision. We understood this by looking at this one. Second one is, if it's a two-dimensional motion, remember, wherever the object is colliding along the line of impact. How do you measure line of impact? The line of impact is the line at which the first object tries to travel. There is a line connecting the first object and the second object. Okay, before collision, that line is what you should consider, and with respect to that line, you should use your COM. Okay, now how do we do it? Now we understood the logic here. So this is the velocity v, this is the velocity here, and then what you do is resolve this velocity along the line of impact. So along this line of impact, this could be 2 cos 60 and this could be 2 sin 60. Anyway, I am not bothered about this one. Now similarly here, this should be v cos 41. Okay, and here you will once again, if you want, again resolve this also, v sin 41. But do not equate these two. This is not required for you. Okay, you are only supposed to do this one here. So towards it, now what do we do here? You will write what is the initial momentum. Initial momentum before collision is nothing but 0.3 multiplied by 3 should now be equal to, what is the momentum after collision? This should be 0.3 multiplied by 2 cos 60. 2 cos 60. This is the momentum of the first ball along the x-axis. Now what is the momentum of second ball along the x-axis? This should be plus 0.5 into v cos 41. This is what we need to do. Okay, do not add both the masses because it's not sticking together. Okay, now let us try this one. This should be 0.9 is equal to 0.6 cos 60. What is cos 60? Half into half plus 0.5v cos 41. I'll write what is cos 41. Let me find out what is cos 41. Cos 41. I will take trigonometry. I'll take 41. Trigonometry, cos of that value should be equal to 0.75. Okay, so I will write this as into 0.75. Okay, now let us solve this. So this should be 0.9 is equal to 0.3 plus 0.5 into 0.75. What is it? This is half multiplied by 3 by 4, right? Plus a half v into 3 by 4. Okay, I need to do it faster, right? So this should be 0.6 should be equal to 3 by 8 v, or v should be equal to 3 1s are 3 2s are, v should be equal to 0.2 multiplied by 8. 0.2 multiplied by 8, which should be equal to 1.6. Answer is 1.6. Got it, right? Without using calculator. Okay, so this is the way how you need to do this problem.